Good evening, sir.
Hey, dearest, how you doing?
I'm tired. I'm actually very sleepy.
Hey, try get it out of you. Yay. And I don't appreciate all you guys laughing after me, with a scene a moment. You're not supposed to be laughing at me.
Yes, sir.
No, I don't appreciate it. I really don't appreciate it. As a matter of fact, I am terribly offended. Right? I'm terribly offended.
No,
Right?
sir. What were we supposed to do? Hmm?
You're supposed to pity
What were
your
we
teacher and
supposed
said, never mind, teacher. Right? I'm terribly offended. All right.
to Sir,
So I
are you said the training or are you say we
I
laugh at
am
each
going
other?
to I am going to take this further because I am offended by the way in which you guys laugh at me and the things that you say
What?
in your minds about me.
Go on, sir. Go on. Go on, take it.
I'm saying to myself, but I don't understand. And excitedly, 4:45 you log on into the class. I say, all right, class will start. Yeah. And then I'm there walking up and down on campus because I was on campus. What is happening here? Why is it that the thing not working? I'm mid there going on and I went to a different location. I said, no man, something is wrong. It's ICT. I was in a call, and then no, you come on, I say, see?
And then, sir, your agitation showed so much in the text, made it even funnier.
She's being a Jesus. She
Where is it, sir?
AC is all right.
Sir, tonight I don't have any internet again, so I'm using data from my phone. But thanks for the laugh. If you're speaking, sir, I'm not hearing you.
Oliver, how you do?
Lovely, sir. Lovely. How about you?
Boy, did take it easy, Had I seen a moment earlier today, but AC laugh it is gone, but I'm good. Could be worse. Could be worse. I'm giving thanks. All right, just wait until the others coming. Give me a few minutes here.
Today.
Say it again.
Yes, I told you that one for yesterday.
Oh, Jesus, man, tell me about it. Ja. I headed out to, well, I intended to go to Crossroads and then to Portmore, and I can't toddy because there was no way I could move. No way I could move. It was rough, man.
Should I show no make you swing by with the arc?
Ah, Oh, goodness. I'll come in. Give me a minute, please.
Yeah, man.
All right, just a few more minutes for the others to come in, and then we're going to begin. Just a few more minutes, and then we begin. All right, guys, ready or not? Oh, other person came. Okay, all right, other person's here now. So I have shared a document that says piecewise function, and it is speaking about some prerequisite knowledge. Speaking about some prerequisite knowledge, factorization, and I want you to take a few minutes. I hope you were doing that before, to go through the factorization here that I have on the screen. Okay, all right. So take a minute or two to go through those two questions, please. The perfect square and the difference of squares, please. All right, so I keep dropping in and out of the session. Don't know why the internet is dropping. All right, so did you have a look at the perfect square compared to the difference of squares? Can you see the difference between the two? Can you identify them? Do you understand what is happening in terms of the factorizations?
Still trying to pick up a difference, sir.
Okay, all right. So let me just go through these two things here with you first. Very important stuff to look at for the rest of this semester and into next semester, God's willing, when we'll be moving into calculus 2, them factorization will come back to haunt us. They're going to come back to haunt us. But it's not difficult. So if you're given something like x squared plus 2x plus 1, and we're factorizing, as I would have given to you before, you're multiplying the coefficient of x squared by the constant. You're multiplying the coefficient of x squared by the constant. So the coefficient of x squared is a number in front of x squared. That is being multiplied by the constant, which is 1. So 1 times 1 is 1. I need two numbers. When multiplied together gives 1. And only two numbers multiplied together and give 1 is 1 and 1. But when added, we give 2. Yeah, man. 1 plus 1 is 2. So my factors are going to be 1 and 1. So I'm breaking up my 2x into 1x and 1x. I'm breaking up my 2x into 1x and 1x. So when I group, remember, we group the first two terms, leave out the middle sign every time. Leave out the middle sign every time, and then we group the other two, the last two. And then I'm in the first parentheses, I'm asking what is common between x squared and x, and the response is x. What is left? X plus 1. And then I'm asking a question, what is common between x and 1? And my smart response is going to be 1, because 1 is a factor of everything. So what is going to be left is x plus 1. So when I look now to see what is now common between x times x plus 1 and 1 times x plus 1, is going to be x plus 1. So when I take out the x plus 1, I'm going to be left with x plus 1. So I'm going to have x plus 1 times x plus 1. And that, because it's a perfect square, same thing in the first parenthesis, is the same thing in the second parenthesis. So it's going to be x plus 1 all square. And that's how we get the perfect square. That's how we do. We evaluate a perfect square. When the term in the first bracket or parentheses is equal to the exact term in the other parentheses. Now, I was asking, do you see the difference between the first and the second? And I'm waiting for a response. Can you recognize the difference between the first one and the second one? The perfect square and the difference of squares?
The symbol, sir.
So one have
Negative
minus
versus
and one has
positive.
plus.
One has minus, one has plus. I hear the symbol. All right, explain what you mean by symbol, and then I'm going to come to you with the one of minus and one of plus.
The plus and the minus sign, sir.
Plus and the minus sign, where that?
Yes,
In the
sir.
answer part?
Not the factorizing
In the
section.
factorizing. Okay. Anybody see something? Anybody see anything? Because there are two things that you should see.
So what about the placeholder, sir?
Also in the result.
What
Also in
about
the
the
result.
you seen it in the result? Okay, what are you seeing in the result?
With the perfect square, I'm seeing x plus 1, x plus 1. When the difference of squares, I'm seeing x minus 1, x plus 1.
Very good. And that's why it's called the difference of
And
squares,
the
because
square in the
one of them
response. Okay.
one of them is positive and the other one. So everything's the same. So in the perfect square, you recognize that everything is the same. In the difference of squares, everything is the same with the exception of the signs. One of the signs going to be plus, one of the signs going to be minus. You can also have a perfect square where you have like x minus 1 and x minus 1, Perfect square means that the signs are just the same. Everything is the same. Difference of squares is that everything's the same with the exception that one is positive and the other one is negative. Can you see that in these two examples that we look at just now?
Yes.
Yeah,
Yes,
all
sir.
right. There's one other though, and somebody was hinting at it. There's one other. There's one other.
The
Talk to me.
square being the response for the perfect square, sir.
The square, what do you mean by that? Like where you have the x plus 1 all square, that's what you're talking about?
Yes, sir.
All right, yes, you won't have that for the difference of square because it's not a perfect square, but that's not it though. There's something else.
Sir,
Mm-hmm.
the placeholder, sir.
What about the placeholder?
Realize how it's set up, sir. Explain.
Mm-hmm. We have to explain to me. You're talking, man. You said something about placeholder. You're getting warm, so we want to see how well you're thinking. This is a placeholder, so talk to teacher. What about the placeholder?
That 0x, it just look weird to me, sir. 0x.
So look at the line before it then.
When they have two characters, I think for now 3.
Come to think of it, sir, you have a positive 0x. But then you still find the factors.
Yeah, but look at the line before it. But the line before it says,
X squared minus 1.
isn't that the question? When normally start write the question first, or the first thing.
Right, right.
So that's a question. That's a question. Question is x squared minus 1. So what we recognize, what's the difference between that question and the question before that?
The expansion of it, sir. So with the perfect square, you have a constant and you have.
Check the number of terms first.
So you have 3 terms versus 2.
How many terms? Very good. That's what I'm going to look at. 3. Notice the one with the 2 terms. The first term is a perfect square. The second term is also a perfect square.
Yes, sir.
And it is
Sir,
separated by minus sign.
just
Agree
to
with that.
clarify, sir. The x square is what makes it a perfect square, right? You, sir? Sir, if you're responding, I'm not hearing you. As in, you're muted. Did sir say hold on or something?
Well, there's enough issues with the internet. Or with Zoom that kick him out now and then.
Talk to me now. You're saying something and you just
Sir, I've been saying something and I even saying if you're responding, I'm not hearing you, you're muted. And you're muted again. Am I the only one not hearing her speaking?
It's everybody.
Okay.
Okay, can you hear me? Can you hear me?
Hearing you now.
Yeah. Yeah. My my speaking device just keeps going in and out. But anytime I use this headset, you guys complain that you don't hear me so well, so this is why I don't want to use it. But have no option at this point in time. All right. Yeah. So that's what I wanted to see. That the difference of square, it has exactly two terms. The first term in a perfect square, the second term is perfect square, and it is separated by a minus sign. And then the question is when we ask, whenever you get a difference of square, sir, will it always have two terms separated by a minus sign? The answer is yes. All right, so that's just us warm up. This is what we're looking at now. Piecewise functions. Piecewise function. Now, when you hear piecewise, what does it suggest?
Broken into pieces.
Broken into pieces. All right. Anybody else?
So when you say piecewise, as in P-E-A-C-E or P-E-I-C-E?
Piecewise. Piecewise functions. So when you hear the word piecewise, what comes to mind?
Comes in different pieces, sir. Like two different so like how we have differences of squares and perfect squares. You might get a question which has a combination of both.
Okay. Anybody else? What comes to mind when you talk about piecewise? Think about it. Piecewise. Talk to me now. Hello. I need one
I
more.
don't have anything else, sir.
I need one more. There are 8 of us.
It said fragments. Yeah, that's a good.
When I say piecewise, what do you think it is?
So what about fragments?
Fragments. Nice word. AC, you are the host here. The amount of time I get kicked out, Zoom reassign you as host. So when you leave in a session tonight, just ensure that you end the meeting for all from me, please. All right. So fragments. So let us look at it. It says determine f of x if f of x is continuous at x equals -2 and x equals +2 for a given function f of x, and f of x is one function. but it is in fragments. 2x minus 1, x minus 3, and x minus 1. The one you say when x is less than negative 2, when x is greater than negative 2 but less than 2, and when x is greater than 2. Take a minute and just look at that and see if you can associate yourself. Just look at those three functions and see if you see any pattern in how they are written, in what is there, and I'll take your comments in another 2 minutes. Yeah, no, my system, my speaking device. All right, 2 minutes. 2 minutes, 2 minutes, 2 minutes.
What are we looking for in the 2 minutes, sir? Sir? Can one of you tell me what we're looking for, please?
Not sure, but he said something about some pattern.
About what?
About some pattern. Mentioned something about some pattern. I don't know. What he was talking about.
Okay, thanks.
Tell me, what are you seeing with the 2x minus 1 such that, hold on, that semicolon means such that x is less than negative 2. The other fragment of it is x minus 3 such that this one is a double one though. This one says x is greater than negative 2, but it is less than or equals to positive 2. And then the last piece says x is less than 1, such that x is greater than or equal to 2. Tell me what it is that you're seeing with what pops out at you looking at this question, this f of x function. Did anything pop out at you?
The complexity of the different terms, sir.
The complexity. All right. Anything else? Anybody else?
And the lesser than and lesser or equal to and the greater than signs.
Okay. What else? Anything else?
So there's one term that I may be familiar with.
Which term is that?
Which would be a difference of square. Which should be, I'm thinking 2x minus 1 and x minus 1, x minus 3. So I'm guessing that here the difference of squares starts the functions here.
All right. All right. So this is what I want you to see. I see you're thinking very deep, but this is what I want you to see. I'm hoping that you will see. When you look at the function, the function says 2x minus 1, but there's a condition to 2x minus 1. The condition says that it only occurs when x is less than 2. So put it this way. You're only going to buy a chicken back when the money run down. But when the money turn up, you buy an oxtail. So there's a condition to it. Condition is when the money run down, I'm buying chicken back because I have to stretch it now. But when the money enough, I'm gonna buy oxtail. Does that make sense? That deduction that I just spoke about, does that make sense?
Yes, sir.
So there are some conditionalities to you eating chicken back and some conditionalities to you eating oxtail. Then no, there's another convention that says when x is greater than negative 2, but less than or equals to 2, I'm going to be using the function x minus 3. I'm going to be using the function x minus 3. And then there's a final one that says when x is greater than 2, when x is greater than 2, I'm to use a function x minus 1. So pretty much a piecewise function, the piecewise function is telling me what to use and when to use them. Tell me what to use.
Sir,
Yes, ma'am. Go ahead.
so that brings back in the statements of statements of condition for continuity that you were showing us the other night.
Okay, yes, ma'am. That's exactly where we are now. Right. That's exactly where we are now. Okay. And you're going to catch us in another 5 minutes, because what you don't know is that we've done it already. Now, remember now, it says at x is less than negative 2, I'm sorry. X is less than negative 2. I am going to look at the condition when x is equals to negative 2. Do you remember when we were doing the intuitive approach? I said to you that they can ask you, the intuitive approach is from first principles, but they could ask you to do something, another calculation, and that you should never ever use the intuitive approach unless asked. Anybody remember that?
Yes, sir.
Yeah, man.
You said we may not get it on the exam.
Yeah, they don't give you the intuitive approach on the examiner. They don't. Not in its raw sense. But a question such as this, you have to apply the intuitive approach. A question such as this, let's apply the intuitive approach. Watch me. I'm going to show you what I mean by that. And it's not difficult. So any of you sit down and say, boy, sir, no, man, it's not difficult. Let's go. So I'm going to investigate when x is equal to 2. Negative 2, sorry. Not just 2, but negative 2. I'm investigating when x is equal to negative 2. And look what is happening. When x is equal to negative 2, I have two conditions. Let me see. I have two conditions. For negative 2, remember I said to you, for the intuitive approach, when I'm looking at a number, I have to look at both the left-hand side and the right-hand side of that number, true or false.
True.
When you're doing the intuitive approach, I said to you, when you're given the intuitive approach, we have to look at both the left-hand side of the function as well as the right-hand side of the function. We can't just look at one side and just make a statement. And we'll say to you, if you look at the left-hand side and the right-hand side, and they are panning out to be the same thing, we say that the function is of a good behavior and the limit exists. Anybody remember them something there? Everyone. They'll come back now. It's coming back to haunt us now. So at x equals 2, negative 2, I need to look at the left and the right of negative 2. I can't just look at the negative 2 in isolation. I have to look at both the left side and the right side and see what is happening. And if it is of a good behavior, then we see the limit exists. If it is not of a good behavior, we reprimand it and say, go hold a seat. Let's go. Let's go. So I'm going to be looking to the left of negative 2. And I'm also going to be looking to the right of negative 2. I'm looking to the left of negative 2 and the right of negative 2. Look at the function f of x for me. Look at the function f of x. The piecewise function f of x. And tell me which function is to the left of 2. You have 3 functions. Only one of them is to the left of 2. Which one is it?
X minus 3, sir.
X minus 3 is to the left of 2. Okay. Anybody else? Hold on to your answer now, because I will come back and ask you why.
No, sir. I know that.
And that? Which one?
Sir, I think X minus 1. I mix up
one.
Yeah,
one
x minus 3 is to the left one.
left. Awesome. Unless me to the left of 2. Maybe I don't know my left from right.
Talk to me now. I still want to answer now. Which one is to the left of 2?
Wait, sir,
Of
me
negative
draw
2.
one line. You said
Wait,
negative 2 or 2.
Of
Yes, sir?
negative 2. Of negative 2. To the left of negative 2.
So this is left, this is right.
If it's now to the left of negative 2, it will be 2x minus 1.
2x minus 1? Why?
Because to the left of would be less than.
Ah! Tell me if you
Mhm.
lunch today. Tell me if you lunch today, Oliver.
Boy, you know, I hear that. Them, no, everything good for eat, good for talk.
Same thing. Same thing. For next thing, say you go eat some mix up, and then you say, what kind of food that? Crop circle? No man, no man, we can't eat. Yeah, nasty. Yeah. No, but anybody heard what he said a while ago?
Yes, sir.
What he said?
It's to the left, so it's gonna be less than 2.
Okay.
So it's gonna be term 1, function 1.
Very good, Oliver. But my question now is, does everyone else in the class see what he just said and agree with it?
Yes, sir.
Yes, sir.
Good. Good. So what I'm saying to you is, so he looked at the function. This is why I keep saying, just when you get a question, just look on the question, man. Because the question is not there to trick you. The question makes sense. To the left of 2, negative 2, has to be when it is less than 2. If you look at, I thought AC, you were going to say to me, when you're going to draw something, and if I'm investigating at negative 2, remember saying no, at x equal 2. So I'm investigating at 2. So I'm going to look to the left of 2 and to the right of 2. No, to the left of 2, I would expect you to say, no, negative 1 or 0. No. Negative 3 or negative 4, that is. And then to the right of 2, going to be negative 1 and 0. So to the left of 2 has to be less than 2. So yes, Oliver, you're correct. It's going to be 2x minus 1. What is to the right of 2? Which of the functions is representing the right of negative 2?
In the immediate area of minus 2, to the right of it would be x minus 3.
It will be x minus 3. Very good, Papa. It will be x minus 3. Anything you eat, any mix of you eat for your lunch, today, make sure you eat it every day.
Sir, so x minus 1. What's that equals?
What about x minus 1? Let me hear it.
Say it's equal to 2.
Yeah, x minus 1 is equal to 2. What we are looking for now, though?
Okay, I want to know the right of it. It's
No,
greater
but
than 2 still, sir.
no, but which number we're looking at? Are we looking at 2 or are we looking at negative 2?
Oh,
Aha.
that is it.
Aha. Aha. So we're not looking at 2, but we're looking at negative 2. So let me ask you the question, Oshed. Does x minus 1 come into this conversation any at all when I'm looking at x equals negative 2?
Negative, sir.
Negative. Can't come into the conversation. Why? Because I am not, hey, listen to me. You see me, I learned them topic here, and also my teacher teaches me. Rups, and it done. Catch it or leave it. I mean, I'll go through the something with you because more if you see the resemblance of it. X minus 1 has no part to play in this conversation. Why, sir? Because x minus 1 is relating to the function when it is at x equals 2. You have no part to play in this conversation. So the only two functions that have a part to play in this conversation is 2x minus 1, because that part is to the left of 2, and to the right of 2 is going to be x minus 3. X minus 3 kind of knows it all. X minus 3 kind of love the mix up. They could look to the right of 2 first. Let me just go through this calculation, and then we'll go to x equals 2. So because I'm looking at x equals negative 2, and we already identified the functions that relate to the right and left of 2, I am going to assume that x is equal to 2. So anywhere in the function I see x, I'm substituting 2. Yes, sir, that's easy because that's what you always say. Yeah, man. It's the same concept coming back, But the intuitive approach. So put it this way: is the two approaches now coming together? The intuitive approach and the calculations approach. Can you see that?
A little bit.
Yeah, man. And don't let it be a little bit. Let me explain why the two approaches coming in together. The two approaches coming in together because one, I am looking to the left and to the right of the function. So when I look to the left and the right of a function, which method am I looking at?
The intuitive.
The intuitive, right? And when now we say, I will assume say the limit is at this point, I'm just going to substitute it into the function. Which method look at? The calculations method, don't?
Yes, sir. My phone
Yeah,
is
man.
stuck.
Yeah, man.
The
So
calculator.
let's look at the calculations method. Yeah, man. So we're looking at both methods in one. I taught them separately, but we're combining them now for the piecewise function. So look at what is happening. So when this here is anywhere in a function, I see x, I'm putting negative 2 because my investigation is at x equals negative 2. All right? Remember what the question said now? Determine if f of x is continuous at x equals negative 2 and x equals positive 2. Given this piecewise function. So me I determine now. So me investigating what happens at x equals negative 2. Let's go. 2 times negative 2 is negative 4. Negative 4 minus 1 is negative 5. All right, so we're going to put on that. Which other function again was to the right of the, oh, x minus 3. And if x is negative 2, I'm going to have negative 2 minus 3 is going to be equal to negative 5. What can we say about this function? Is it of a good behavior or bad behavior? I think I'm gone again. Anybody hearing me?
Yes, sir. It's a good behavior.
It's of a good behavior, right? It's a good behavior. So listen to what I say now. So since the limit as x tends to negative 2 to the left, or let me show you this. You notice I have a minus sign up here, so, and a superscript minus up here and a superscript plus sign here, so. What do you think the superscript minus is representing?
You're approaching from the left-hand side of
Good, good.
Right.
minus
And then
2,
right, and the plus sign approaching from the.
the right-hand side.
Listen to me now. Let me tell you something.
Sir,
Yes, mommy.
for you, I could do something. Can you call the function where you have the second one, x minus 3, and you have the arrow? What you say, limited to? Same way? Limited
Yeah,
to
no, man. I'm this for me here means that 2x minus 1 is going to now imply. So this arrow here in mathematics means implies, right? So
Okay.
this limit now is now implying that 2 times negative 2 minus 1 is going to be equal to negative 5.
Okay, sir.
Yeah, man. Now hear me out. Is there anybody who get a B plus in my class would have failed the course here? When I forget one A, because guess what? It's not a bad set. Really not a bad group. So I'm depending on you guys to do and do very well. So for those of you who know that you're not pulling your weight and you know that you're not following, say something. Say something. Don't let it run away from you, please. All right, let's continue. So we say since the limit as x tends to negative 2 to the left, which is this function, is equal to the limit as x tends to negative 2 to the right, which is this function, then f of x is continuous at x equals negative 2. The function is therefore continuous. So that's the terminology we're going to be using, continuous. The function is therefore continuous. If the function is not continuous, we'll say that the function is going to be discontinuous. So right here and then we can say the function is continuous. The function is continuous at x equals negative 2. All right? Let us look at x equals positive 2. X equals positive 2. Does 2x minus 1 come into this conversation any at all? Does 2x minus 1
Negative.
come negative? Why?
Because of the range.
It is less than. And once it is less than, it is to the left. And it is negative 2. This one here is, we're talking about positive 2. So
So
it is, so yes, you're correct. It's in the range. So this one, what we're looking at now, the condition that we're looking at now is when x is equal to 2, not negative 2. So so the first one is not a part, will never be a part of this conversation. All right? So now that they've ruled out the one that is not a part of the conversation, you can't, it means that the other two must be a part of the conversation. But you know how to decide which one is to the left of positive 2. Which of the two remaining functions is to the left of positive 2?
So, sir,
Uh-huh.
knowing that we have used, oh, never mind. Both of them is to positive 2. Because I was saying, knowing that we used the two first functions for approaching negative 2, and then the condition for x minus 1 would be approaching positive 2. Wouldn't it be a case that we would only use that? But then I recognize that x minus 3 also has a range to positive 2.
Very good. Excellent. And that's why you see a strategy of mine in teaching. I don't think we're supposed to come from telling everything. I love discovery learning. You know, if I put something on the screen and I said, look through it and look and see the same similarities. I ever do that yet?
All the time.
Because I want you to be able to see and recognize the similarities. See and recognize the similarities. So yes. So you were going to say, sir, but oh, never mind, because I see that the x minus 3 also has a range with the positive 2. And you're correct. Oliver said it too. You're correct. The rest of you, don't sleep on me now. Come on, man. Let us go. All right. So tell me now, which function is to the left of positive 2? Look at it and tell me which function is referring to the left of positive 2.
X minus 3.
Tell me why. You're correct, but tell me why.
Because of the range. Because x minus 1 is actually when x is greater than or equal to 2. So that would be on the right hand side. So automatically the next one become the left hand side.
Yeah. Okay. So that's very good reasoning. Very good deduction, but I don't want to tell me automatically. I want you to look at me and tell me, boy, sir, the range says x is less than 2. See here, sir? It says x is less than or equal to 2. So it's the mere fact that it's less than, it's going to be to the left. All right? But very good, Oliver. Very good. So you're correct. So the function that is to the left of 2, Chevy, new Chev. So the function to the left of 2 is going to be x minus 3. See there? So x tends to the left of 2. Remember, when you're writing your function, you can't just write x tends to 2 and just leave it so. You have to tell me if it's to the left or to the right. Very important. You have to tell me if it's to the left or if it's to the right. All right. Let me ask you to use 2 minutes. Seeing that I have done the first one, which is for negative 2, read through this one and see if you see anything similar to what it is that we've done before, or you understand or agree with what it is that I've done. 2 minutes.
Sorry, speaking? Or what was the last question? I missed it. Sorry. Somebody can tell me what sir did say, please?
So with respect to what?
I missed the last thing he said. With the function. He reached the end of the discontinuous?
You're saying that
I'm drop out of the chat.
you're saying that you must look at these functions. See if you agree with
Must look what?
you must look at these the functions, these units up here.
Yellow here.
See if you agree with affects this continuous. This continuous x unit is positive.
Oliver, you were the one that was speaking just now?
No, somebody else was speaking, but they were speaking a bit low.
Very, very low.
No, I'm saying that you said that we must look at the question here and see if we agree with the decision that is discontinuous.
Oh,
X is
okay.
2.
So if we agree with what he has.
Yeah, and try to figure
Okay.
out how
Why is it discontinuous? Is it because we don't get the same response with the left hand and the right hand side? Bad behavior also? Is that the reason? Anybody? I don't think sir is here. I think his speaking device fell
Oh,
off.
sorry. I just got up. Ask the question again. We'll see if we can help you.
I'm asking, why is it discontinuous? Is it
Okay.
because
Look at the two lines, right? You see the so limit of x minus 3 approaching from the left hand side, right? You take the
mhm,
x minus 3 and you put the 2 into that. which gives you that blue -1 that you see there. In the second line now, you see limit as x approaches 2 from the right-hand side. Yeah, with that function would be x -1. So when I drop in that the 2 in that x, and then your -1, they actually get +1. But the two limits don't correspond. So therefore, that's how you know that it is discontinuous.
That's what I was asking. If it's because both of them don't correspond, if they don't have the same responses, that's why it's discontinuous. Thanks.
All right, cool.
Very good, Oliver. Excellent. Proud of you. You are correct, right to the T. Very good deduction, also AC, because I heard that's what you were thinking. Very nice. Now, topic finish. Topic finish. It's just variations to the question now. So let me just show you something here. There are 5 things that popped out at me, and I want to share them with you. Some of them you've already recognized. Do you recognize that to the left means less than?
Yes.
Yeah, man. And this is a less than sign, and then we're going to have a negative to it. So if it is to the left of 2, we're going to have a superscript negative, right? And of course, to the right means that it's going to be greater than, and this is a greater than sign. And it's going to be positive, right? Just remember, stop and think back to the number line when you're looking at that, to the left and to the right. So if you think of the number line, and if I'm looking at the limit 1, to the immediate left of 1 is going to be 0. Talk truth.
Yep.
Yes, sir.
Yeah, man. And then to the right of 1 is going to be 2. So just think about the number line. And then the second thing is that x tends to -2 superscript means that x tends to the left of -2. That's all it means. X tends to the left of -2. And x tends to, with the plus up here, it means that it tends to the right of -2. So when you're doing your questions, you must indicate the superscripts. So I know that you're talking about the left, and I know you're talking about the right. If it's not there, you're going to be losing your mark. And a question like this, you know, lose marks from them question here. When it's a question like this, you say, thank God, because we can gain marks from here. All right? So just remember, to the left is negative, to the right is positive, but you also did use that before. Number 4, you're going to read inside out. You're going to find your variable. See, you start at x, and you're going to read inside out. So you start at x, and you're reading inside out. So x is greater than -2, but x is less than or equal to 2. X is greater than -2, and x is less than or equal to +2. You read inside out. Always. Don't read it like this. -2 is less than x, which is less than or equal to 2. This don't mean nothing. But when you read it the other way, you know, inside out, x is greater than -2. Oh, but if x is greater than -2, it means that it's to the right of -2. But x is less than or equal to 2. Less than or equal is to the left of 2. Right? So you recognize that the middle function deals with both values, -2 and 2, but one goes to the left and one goes to the right of it. All right? And since we read from the left to the right, once the inequality sign opens to u, then it is greater than. In other words, the mouth of the alligator is open, boom, it's greater than. Otherwise, it is less than. The mouth of the alligator is closed, like so, it is going to be less than. Any questions?
No, sir. I think
You think you get it?
yes, sir. I think I just need to solid
Just,
on my left and right and my signs. I think that
okay.
comes with practice. So yeah.
Oh,
Alright.
sir.
Yes, Poppy.
Sir, so each question have different principles?
No, you can't get a straightforward question like this. but you can also get a question where, and I'm going to do that in a few, not maybe, I'll definitely do that on Thursday, possibly, where you get unknowns and you're asked to evaluate those unknowns. Right? But it's just the topic finish. What is left to be done now is just variations. So I'm going to give it as many variations to the question so that whichever variant is given in the exam, you know what to do. All right. I'm going to see if I can open. And this is not helping me. It's not helping me because all right. So that's not helping me. All right. Let me see how much you remember from the. I want you to attempt that question. Don't worry about sketching the graph of this function yet. Don't worry about sketching the graph of the function. Right? Don't also worry about how the function looks. The function may look very ugly. Don't worry about that. Don't worry about that. It says determine if g of x is continuous at x equals -4 and x equals 1. But sir, a while ago, you do the question with -2 and +2. You know, some only things only -2 and +2 could use? No. But some of the also things are the same. So if you look on 3, you have to look on -3. And if you look on 4, you look on -4. No. You can look at -4. You can look at 1. You can look at 4 and 0. Any combination that the question gives, you can look at it. Right? So don't start thinking stereotypically that it's only this way alone that can answer the question. So that's why I'm saying to you that I'm looking at variations to the question. All right, look at that for me. I want you to make an attempt of this question. This question is asking us to check continuity at x equals -4 and also for x equals 1. So you're going to look for the equations that associate itself with -4 and the equations that associate itself with +1 and work it up. On the mark, get set, go. Khalil? Khalil? How's it going? How's it going? Somebody?
Sir, are you saying something to us?
Yeah, I'm gonna ask you how's it going?
It's going, sir. I keep hearing mumblings. I didn't know you were talking to us.
Hey man, I was asking how the calculation you okay, so you finish x equal negative four
Minus
already?
4. Yes, sir.
Is it continuous or discontinuous?
It's continuous.
What the rest of the students in the class say? Do you agree with her?
Agree.
Okay, one person agree. Anybody else?
Agreed, sir.
Okay, okay, stand on. Here it is. What about the rest? Sabrina, um, Callie. Oh, Callie not in class. Alright, so I'm hearing that it's continuous. Let us check. Uh-oh, that's what you got?
Yes, sir. I got 1.
Very nice.
Yes.
Very nice. Now, do you agree with me that this is not difficult? Just takes a little patience for you to look at what it is you're supposed to look at and you're good to go.
And a little practice, not just
And a little,
patience.
yeah. Yeah, man, you can get a little, and trust me, it's a pity you don't know how much practice you can get tonight. Yeah, man, you can get enough practice, man. All
Sir,
right? Yes, ma'am.
I cannot say it's not difficult because guess what? The teachers always teach easy
Go away and leave me alone. Go away and leave me alone.
and leave us to figure out the difficult part. You hear what you said a while ago, sir?
Leave me alone.
How
Leave me
much
alone,
practice we
AC.
are gonna get? Which means I will one man can come for them over here, so sir.
Oh, Lord. Today, this pick on me, like the AC. No, man, you're good, man. You're good. You guys, you see the thing about it? But I'm happy about some groups that I've had in the past. I don't reach here in the first class because I have to go back through the stuff. So the mere fact that you guys are at the point where you're doing a question on your own, you're good to go. Remember I said there are different variations. So same chicken, where you can fricassee it, curry it, fry it, jerk it, barbecue it, and boil it. Yeah, so it's the same chicken, but I'll show you how to navigate the different methodologies. Trust me, you're gonna like it, you're gonna love it, and I'm gonna tell you a secret. The topic of the next semester, and the final exam too. So you're good to go. All right, quickly. Do x equals 1 for me, please. Let me see what it is that you get from there. You get it right. We just call it a nine. Take your time on this.
Sorry, what does sign mean again? The sign in the second function going to
This
1.
This one?
No man, back at g of x. In the question itself.
This?
2x plus 9.
Oh, such that, right? X is greater than -4, but less than or equal to 1.
Less than or equal to 1. Okay, thanks. Sir, the 1 continues as well.
Is it?
Say that again?
I'm asking, is it?
Yeah.
It is.
Okay. I don't think so. I don't think so.
Sir, prove. Why
Yeah,
you don't?
right. Because the nose in a bright. That's the problem. And then not a bright. No, but no, seriously, guys. I'm very encouraged, and I have gone through a period with a set of calculus 1, calculus 2 students that I prayed for a breakthrough period, and this looks like my breakthrough period. I'm not saying that the other students are bad, but some of them struggled, and it put me under a whole heap of pressure. It looks like this is my breakthrough year, and I have taught a calculus class before where everybody in the class passes. Right? So this looks like it's going to be my breakout year, and I'm very excited. Congratulations, guys. So just gonna do one pick little thingy to show you something. You notice this is 11, and you find the limit of it. The limit of a constant is a constant itself. Just remember that. The limit of a constant is a constant itself. So the limit of 11 is 11 because I don't have a variable to substitute in. So the limit of 11 is 11. Just remember, the limit of a constant is a constant itself. You'll come up against that many more times. The limit of a constant is a constant itself. The limit of a constant is a constant itself. Big up on yourself. See you on Thursday. We're going to run through some more, and we'll see if we can finish off this piece, guys. All right? Thanks for coming out.
All right, sir. Have a good night.
To you too. Remember, I want you to end for all for me, please. Yeah?
Yes, sir.
All right, cool. Take care.